this is such an awesome experience to get up close and personal with the Curiosity rover. I mean, this isn't the exact one that's on Mars, obviously, but it's basically identical. I'm here at the Jet Propulsion Lab in Pasadena, California. I don't know how we got in here, Bill. It's amazing. This is the NASA center that's famous for building things like the Mars rover, space probes, and rescuing Matt Damon from the Red Planet. You guys must get pretty sick of answering questions about the Martian.
Yes.
This is project scientist Ken Farley. I spoke with him about life on Mars. He's one of many scientists working on the first NASA mission in 40 years, designed specifically to look for life on another planet. It's called Mars 2020. If there were life on Mars, wouldn't we have found it by now?
No, we would not have found it by now.
But we've been looking. There's been a number of missions like the Viking landers and like Curiosity, for example. Part of the problem is we're not even sure what we're looking for. Life on Mars may have been completely different from life on Earth. Recent missions like the Curiosity and Exploration rovers looked for and found evidence of water, a key ingredient for life.
Follow the water. Where was the water and when was the water? And then looking for habitability, looking for places that could have supported life. Now we know enough about Mars to look for ancient life instead of anything on the surface of Mars today.
There's no life on the surface of Mars today.
Most likely, if there is life on Mars today, it would be underground, underneath the ice caps, in places that are very, very hard to investigate with the sort of rovers and landers that we've sent so far.
So we're talking like moles, groundhogs.
Well, microscopic bacterial moles. No, not actual moles. We're looking for, we call them biosignatures. It's a pattern or a substance in the rocks that can only have been formed by life.
To find those biosignatures, the 2020 rover is going to need cutting-edge technologies developed here at JPL. But for definitive proof of life, they'll need drill samples.
We need to take a core that's about the size of a piece of chalk. We have to collect 37 tubes like this that will ultimately be laid on the surface of Mars for possible return in the future.
Mars 2020 is different from past missions because now NASA will need to bring those samples back to Earth to test them for evidence of life.
If they are brought back to Earth, we will be able to use all sorts of different kinds of techniques, many of which have not yet even been invented because nobody has been posed with this question.
So in order to find life, we'll have to return those samples from Mars, something that's never been done before, and test those samples with techniques that haven't even been invented yet. So I had to ask, how good do you think your chances are of finding life?
I'd say they're poorer than even, just because I remain skeptical. Regardless, we will learn about what the early history of the solar system is like. And that's the same environment, the same solar system that Earth was in when life was evolving. If you want to understand the origin of life on Earth, because that's the only place we know life exists, the rocks that recorded that are all gone.
So in a way, looking at Mars is like looking at a version of Earth frozen in time right about when life would have sprung.
That's, I think, the most exciting way to look at it.
It's just unbelievable. The stuff that is happening here is just so far beyond anything else. Like, what are you doing today? Are you sitting in your cubicle? Are you working on your computer? Okay, these guys are working on a freaking machine in outer space on Mars that is trying to discover life. This is cool. That was one of my field pieces from the Netflix show Bill Nye Saves the World, on which I am a correspondent. If you haven't seen it, you should check it out. But obviously, because that show is for a broader audience, I don't get to go into the kind of crazy detail that I sometimes do on this channel. For example, this image is the first ever beamed back from the Martian surface. It was taken by the Soviet lander Mars 3 on December 2nd, 1971. After becoming the first man-made object to make a soft landing on Mars, that lander transmitted data back to Earth for just 14.5 seconds before going quiet. And no one really knows what happened to it, but it might have had something to do with the huge dust storm that was taking place at the time. Now, this is the first clear image sent back from the Martian surface. It was taken by the Viking 1 lander on July 20th, 1976. And one of the stated aims for that mission was to try to find evidence of existing life on the Martian surface. And there was this experiment called the labeled release experiment, where a scoop of Martian soil was taken and then a dilute solution of nutrients was added into that soil. But In those nutrients was the radioactive atom carbon-14. And the idea was, if you tried to detect the gases around the soil, if you detect some radioactive carbon dioxide, you know that the nutrients were broken down by something in the soil, presumably something that's living. What was remarkable about this experiment was that it got a positive result. There were a few other experiments trying to detect life in other ways, and they failed to get a detection. But this one detected radioactive carbon dioxide. And what's even more impressive was the Viking 2 lander, which tried the same experiment after the Viking 1 lander. It also got the same positive result. So things were looking promising. But then, about a week later, they tried to rerun the experiment, add a little bit more nutrients to the soil and see if you could get more CO2. But they couldn't. There was no additional CO2 released. So based on these negative results and the negative results of the other experiments, most scientists have concluded that there is no surviving life on the surface of Mars today. So how is the CO2 produced in the first place? Well, chemists suspect that very highly oxidizing chemicals, things like perchlorates, exist in the Martian soil and would have reacted with the nutrients producing the CO2 to start with. But once those chemicals are used up, well, there's nothing for those nutrients to react with, and so we get no CO2 the next time the nutrients are introduced. This story highlights just how difficult searching for life is using only remote instruments. And that's why for Mars 2020 they're going to create some rock samples that should be returned to Earth, if only they can get the budget for another mission that will go back and pick them up. But the rover they're sending in 2020 will also have some new tools on board that will allow them to look at rocks in finer detail than ever before. One tool, called Pixel, will use X-ray spectrometry to try to detect chemical elements with a spatial resolution that goes down to the size of a grain of salt. Now, what they'd be looking for are layered structures, similar to stromatolites found here on Earth. Those are mineral deposits which get built up by billions and billions of tiny organisms. So you're not really looking for fossils or for tiny little, microbial evidence. We're looking for the structures that they would have produced, layered structures. That's how we know about the oldest life on Earth, and so it's logical to think that's how we might find out about this old life on Mars. And the job of finding evidence of past or current life on Mars is made even more difficult by planetary protection. That's the principle whereby we should not introduce any life from Earth to these places where we're studying, like Mars. And that's completely understandable because, the worst discovery of life we could make on Mars would be life that we introduced there by our spacecraft. Certain organisms are really hardy, even in the vacuum of space and even when bombarded by radiation. But due to this constraint, spacecraft must be strenuously sterilized, and also they're restricted from landing near sites where we think there may be liquid water. I'm really looking forward to the results of the Mars 2020 mission, and hopefully a later mission where we actually go back and collect the samples that were placed there. But one thing that really struck me from my interview with Ken Farley was when he said that Mars is really like a time capsule of the rocks that Earth had when life evolved here. That's a way I'd never really thought about it before. But of course, because of plate tectonics and all the weathering that have taken place on Earth, we don't have the rock record from when life was first evolving on this planet. And that makes Mars a really good place to look not only for new forms of life, but also for an understanding of how life on Earth may have begun.